Hello, my dear friends. Let us continue learning. Probably in the last session you have learnt about binary search algorithm. There at the end of binary search algorithm you have clearly understood that if at all binary search algorithm has to work properly, then you have to give the input in the sorted order or in the ascending order. Well, what if the user will not give the input in the ascending order? What if the user will not place the contents of the array in the ascending order? Then it would be programmer's duty to sort it and give it to the binary search. How to sort, sir? Or how to arrange it in the ascending order, sir? If you will ask me, very simple. There are multiple sorting techniques or sorting algorithms. You have something called as bubble sort, selection sort, insertion sort, merge sort, quick sort. Many sorting techniques you have. In that, one of the sorting techniques we will be learning today. Please do take the heading as sorting by using bubble sort algorithm. A very important topic as such, carefully watch it. Say supposing, of course, most of you by now understood that sorting is the process of arranging the data either in ascending or in the descending order. That is what is the meaning of sorting. But now I am interested in arranging the data in the ascending order. Say supposing user has entered the data like this in an array. 86, 42, 23, 18 and 25. Say supposing like this user has entered. Correctly look at the contents of the array and tell me, are they in the ascending order? Or are they in the descending order? Certainly not. They are in the random order. Now I want to arrange these elements in the ascending order, or I want to sort these elements in the ascending order. Okay, sir, how to sort? That is what I am telling you. Using bubble sort algorithm, I have to sort, it seems. Okay, sir, what is that algorithm? How that algorithm would work? Like this. Carefully watch it. Here I would tell, take the first element. This is how the algorithm would go. Take the first element, compare the first element with second element. That is what you have to do. If first element is greater than the second element, then you have to swap it, it seems. Look at it. First element is 86, second element is 42. Is 86 greater than 42? Yes. So swap it. Swap it means exchange it. If you will exchange it, 42 would come here, 86 would come here. Am I not correct? Remaining elements are untouched. I did not touch only. All they are like that only. Okay, sir. Next one. First element you compared with second element. Like that you have to continue until nth element. Second element continue with the second element, compare with the third element. If you ask me, sir, how? Look at it. Now this is second element, this is third element. Look. Take the next element, compare it with its next element. If the next element is greater than its next element, then again swap it. Look at it. Is 86 greater than 23? Yes. 86 is greater than 23. If it is greater, then swap it. Like this, swap it. If you will swap, then 23 would come here, 86 would come here. Remaining elements, look, this side 42 I did not touch, this side 18 and 25 I did not touch only. First element compared with second element compared with third, continue, third with fourth, like that. Take the third element, compare it with its next element. If third element is greater than its next element, then swap it. That is what you have to do. Is 86 greater than 18? Yes, it is greater. So you have to swap it. These two you have to swap. If you swap, 18 will come here, 86 would come here. Remaining elements, either it is this side or that side. I did not touch only in this. So 23 will be here, 42 will be here, 25 will be here. Well, I should not stop. I have to continue. Still, I have two more elements to compare. Take the next element, compare it with the next element. If 86 is greater than 25, then swap it. Is 86 greater than 25? Yes. Then you have to swap. If you will swap, 25 would come here, 86 would come here. All the other elements, if you will see, 18, 23, 42 is untouched. By the end of first iteration, look at it, I have started with the first element comparison. I have compared its next, I have come till the end. This I will consider it as first iteration. By the end of first iteration, if you carefully see, one element I have taken and I have given its position in the ascending order. You only see 86, if these are the elements, and if you are planning to arrange it in the ascending order, 86, where it will come? Certainly it has to come to the end of the number. So 86 has come to its place. Or in other words, if I want to tell, 86 has bubbled up and has occupied its position. So one element is sorted, the remaining 4 is unsorted. So that 4 I have to sort it. Look at it. These are those 4 elements. 42, 23, 18, 25. Well, 86 I would not touch because 86 is already sorted. 86 is sorted. I would not touch 86. It has got its position. I have to sort these 4 elements. If you ask me, sir, these 4 elements how to sort? Whatever you have done here, same thing, repeat it. Means go again from the first element. Take the first element, compare it with its next element. If it is greater, then swap it. If you swap, 23 will come here, 42 will come here. Am I not correct? All the others, 18 and 25 is untouched. Of course, 86 I will not touch only because it is already sorted. 86 I don't have any relation. I will leave it. Move ahead. Again, take the next element, compare it with its next element. If it is greater, then swap it. Is 42 greater than 18? Yes. So swap it. If you swap, 18 will come here, 42 will come here. Remaining elements, which is 23 and 25 is untouched. Forget about 86. I have already forgotten 86. I don't have any relation with 86 because it has got its position. We'll continue. Take the next element, compare it with the next element. If it is greater, then swap it. Is 42 greater than 25? Yes, it is greater. Then swap it. 25 will come here, 42 will come here. 18 and 23 is untouched. Like that, if you see, one more element by the end of second iteration, one more element I have taken and have given its position, or in other words, one more element has bubbled up and has got its position. 86 already got, forget about 86. Now 42 got its position. So by the end of second iteration, one more element. See, this 4 only we have to sort because that is sorted. We have started from here. We came until that 4. By the time we came there, one more element got its position. It has come, it has bubbled up and has come to its position. Next, I have to sort remaining 3. See, this 3 is not sorted. These 2 is sorted already. These 3 I have to sort. 23, 18, 25. Like this. Look. 23, 18, 25. The remaining 2, 42 and 86, I really don't have any relationship with them because they have already sorted. I will not touch them only. 42 and 86. But this 3 I have to sort. How will you sort? Same way. But now somewhat technically I would speak. If variable j is handling the indexes, my assumption j is handling the indexes. So if j is handling the indexes, I would tell if array of j, if j is 0 initially, if array of j is greater than array of j plus 1. See, if array of j, if j is 0, is array of j 23 greater than array of j plus 1 18? Yes. If it is greater, then swap it. If you swap, 18 will come here, 23 will come here. 25 I did not touch only. 42 and 86 I will not touch only. Forget about in future. I will never touch. 42 and 86 have got its position. I would continue. J plus plus. Array of j is greater than array of j plus 1. Is 23 greater than 25? No, it is not greater. If it was greater, you swap. If it is not greater, don't swap. Without swapping, leave it. If you will not swap, then 23 will be there only. 25 will be there only. I did not swap because it is not greater. 18 will be there only. 18 will be there only. 42 and 86, I would not touch. Like that, if you see, this 3 is what we thought of sorting, we thought of arranging. Started from 1 until 3 we came off. By the time we ended at the third element, one more element have bubbled up and have got its position. These two we have to sort. I know for the human eyes, it would be like, sir, it is sorted, no sir. After 1823, sorted, no sir, like that you might think. But for computer's eye, still this 2 is not sorted. If you see, 5 elements are there. One element it gave its position, next element it gave its position, next element it gave its position. These 2 still are pending according to computer or according to algorithm. So that 2 I have to sort, 18 and 23. The remaining 3, 25, 42, 86. 25, 42, 86 is untouched. They are really untouched. Okay sir, next what? Look at it. Again, make j as 0. Is array of j greater than array of j plus 1? No, they are not greater. If it was greater, we could have swapped. They are not greater. So I would not swap. I will keep it there only. 18 will be here only. 23 will be here only. 25, 42, 86. See, 25, 42, 86 is there. By the end of the 4th iteration or by the end of next iteration, look, we thought of sorting these two, sorted. By the end of that iteration, look at the array. Array contents are really sorted. 18, 23, 25, 42, 86. Now whatever you are seeing here on the board, this is what is bubble sort algorithm, and this is how your bubble sort algorithm would work. This is how it would work. You have to start comparing the first element with its next element, the next element with its next element, the next element with its next element, the next element with its next element. Like that, one iteration if you will complete off, by the time of first iteration, one element will get its position. Like that, second time, second element, third time, third element, fourth time, fourth element. How many number of elements are there in the array? 5 elements are there in the array. If 5 elements are there, you have to do 4 comparisons like this. In every comparison, one element would be bubbling up and would be getting its position. If 4 elements will get its position like this, see, in this iteration this got, in this iteration this got, in this iteration this got, in this iteration this got its position. 5 elements are there. In 4 iterations, one element, if it gets one position, automatically 5th will be in that position only. 5 students are there. 5 students are there. I will tell 4 students, I will tell all 5 students, arrange yourself in the ascending order of your height. 4 students correctly went and stood in their position. The 5th one certainly will be taller than everyone. Certainly he should go at last. Or if 4 probably have stood at their according to their heights, one more wherever he will fit, they will go and stand off. It will be sorted only. Am I not correct? If 4 elements get its position, one automatically will get the position. That is what has happened. 86 got, 42 got, 25 got, 23 got. 18 automatically will get, it got. So 5 elements are there, means 4 iterations you have to do. But say supposing, let I, variable I, take the responsibility of counting the iterations, and let I start from 0. See, this is 0th iteration. I would write it full to you. This is 0th iteration. Say supposing this is first iteration. This is second iteration. This is third iteration. Zeroth iteration, first iteration, second iteration, third iteration. Say supposing I am counting like that. 5 elements are there. How many iterations I took to sort the elements in the ascending order? 4 iterations I took. But that 4 count is starting from 0. So from 0th iteration until 3rd iteration. If there are 5 elements, 4 iterations it would take, means from 0 to 3. From 0 to 3 is 4. 5 elements means 0 to 3. 6 elements means 0 to 4. 7 elements means 0 to 5. 10 elements means 0 to 8. 9 iterations only, but 0 to 8 is 9, no. 100 iterations means 0 to 98. 0 to 98 is 99, correct. But I am starting from 0, so I would tell 0 to 98. If there are 100 elements, starting from 0th iteration, if I do the iteration until 98th iteration, elements should be sorted. But one thing we have to keep in our mind. In every iteration, I am doing something. If you ask me, sir, what are you doing? I am doing comparison. Look at it. That is what I am doing. Comparison I am doing. Whether first element is greater than with its next element, the next element with its next element, the next element with its next element, the next element with its next element. Again in second iteration also same thing. First with second, second with third, third with fourth. Again in the next iteration also same thing. First with second, second with third. Like that I am doing. Comparisons I am doing in each iteration. How many comparisons I am doing? That also let us see. I would just assume that this is 0th iteration, 0th comparison. This is first comparison. This is second comparison. This is third comparison. Just because I am starting from 0, it is ending at 4. Actually speaking, 1, 2, 3, 4 comparisons I am doing. But let me start from 0. 0th comparison, first comparison, second comparison, third comparison. Means in the 0th iteration, actually I am doing from 0th comparison to third comparison. You only see, from 0th comparison to third comparison I am doing. Now let the number of comparisons be taken care by J. Let J take care of number of comparisons. Here how many comparisons I am doing? Let me see. This is 0th comparison, this is first comparison, this is second comparison. Means again, if J is taking care of number of comparisons, I am doing comparisons from 0th comparison to second comparison. Like that, this also if you see, this is 0th comparison and this is first comparison. So here I would tell J would start from 0th comparison, go until first comparison. Here I am telling this is 0th comparison. Again if J is taking care of number of comparison, I am actually doing from 0th comparison to 0th comparison only. 0 to 0 only. There only I am stopping. Am I not correct? Yes or no? Like that if I will see, carefully watch it. If number of elements is 5, if there are 5 elements to be sorted, then I am starting from 0th iteration, I am going until 3rd iteration. In every iteration, if number of elements is 5, then I am starting from 0th comparison, going until 3rd comparison, from 0th comparison, second comparison, from 0th comparison, first comparison, and 0th comparison to 0th comparison. Now there is no standard in every iteration I am doing some comparisons. Here some number of comparisons I am doing, here some number of comparisons I am doing, here some number of comparisons I am doing, here some number of comparisons I am doing. So let me bring it to one standard form. If you look at it that way, see, actually speaking, from 0th comparison, I am actually doing n minus 2 minus I comparisons. If you want, you can see. What is that, sir? From 0th comparison, you are doing n minus 2 minus I comparisons. Yes. What is n? N means number of elements. How many number of elements are there? 1, 2, 3, 4, 5. 5 elements are there. What is 5 minus 2? 3. What is I value here? I is 0, 0th iteration. 3 minus 0 is 3 only, correct? 0 to 3 comparisons I am doing. 0 to 3 comparisons only I am doing. Not only here, here also if you see, from 0th comparison, I am doing n minus 2 minus I comparisons. Yes, if you want you see, what is 0 to, n is 5, even now 5 only, 5 elements are there you see. 5 minus 2 is 3, 3 minus, what is the I value? 1. What is 3 minus 1? 2. So from 0 to 2, 0 to 2 only, correct only, no? Like that here also, in the second iteration also, actually I am doing from 0 comparison to n minus 2 minus I comparisons. If you want, you can see. That is what I am doing. Look, 0th comparison 2. What is n value? N value is 5 only. 5 minus 2 is 3. 3 minus, what is I value? 2. 3 minus 2 is 1. Correct, 0 to 1 comparison. Correctly I am doing. Not only here, here also I am doing the same thing. If you want, you can see. Number of comparisons is starting from 0 is going until n minus 2 minus I comparisons. What is n value? 5. 5 minus 2 is 3. 3 minus I is 3. What is 3 minus 3? 0. Correct. 0 to 0 comparison I am doing. So let me summarize the things to you like this. In bubble sort, if there are n elements, I repeat, in bubble sort, if there are n elements to be sorted, then you have to start from 0th iteration. You have to go until n minus 2 iteration because 5 elements are there. I am going from 0th iteration to n minus 2, 3 iteration. That is what I am doing. If there are n number of elements, start from 0th iteration, go until n minus 2 iteration. N minus 2 iteration, 5 minus 2, 3. In every iteration, I am doing comparison. How many comparison? Starting from 0th comparison, I am doing n minus 2 minus I comparisons. In every iteration, starting from 0th comparison, I am doing n minus 2 minus I comparison. In every iteration, I am doing from 0th comparison to n minus 2 minus I comparison. In every iteration, I am doing from 0 to n minus 2 minus I comparison. That is what I am doing. Oh, okay, sir. Next what? Can you please write the algorithm? Certainly, yes. Whatever I have told orally, the same thing I would write it. Look at it. If there are n number of elements to be sorted, then according to bubble sort, I have to start from 0th iteration. Correct. I have started from 0th iteration. I have to do the iterations until I less than or equals to n minus 2 I plus plus. Correct only. N minus 2 only. 5 elements are there until 3 I went. If n is 5, 3. So 5 minus 2 is 3. Oh, correct, sir. Next what? In every iteration, what we are doing? Comparisons we are doing. How many comparisons? 0 to n minus 2 minus I comparison. Who is taking care of comparisons? J. That is what I would tell. Look, start from j equals to 0. Correct. In every iteration, we are starting from 0 only. From 0th comparison only, you can see. In every iteration, starting from 0th comparison. Comparison going until where? Number of comparisons is going until j less than or equals to n minus 2 minus I j plus plus. How are we doing comparison? Like this, we are checking if at all that the array of j, whatever you have, is greater than array of j plus 1. That is what we are doing. If j is 0, is array of 0 greater than array of 0 plus 1, 1? If it is greater, we are swapping. If j is 1, is array of j greater than array of j plus 1? If j is 2, is array of j greater than array of j plus 1? That is what we are doing. That is what I am telling there. Every time, in every comparison, we are checking whether array of j is greater than array of j plus 1. If it is greater, we are swapping. What we are swapping? We are swapping array of j and array of j plus 1. That is what we are doing. Oh, okay, sir. If it is greater, we are swapping. If it is not greater, sir, we are just continuing. That's it. We are just continuing. Continue. This is what is the bubble sort algorithm. That's it. By the end of fourth iteration and by the end of all the comparisons of fourth iteration, if elements is 5, certainly elements are in the ascending order. You can see. By the end of the last iteration, elements automatically will be in the ascending order if this is followed. The same thing we followed. See how easy bubble sort algorithm is if you will understand it properly. 5 n elements are there. Starting from 0th iteration, go until n minus 2 iteration. In every iteration, you are doing comparison. How many comparison? Starting from 0th comparison, you are doing until n minus 2 minus I comparisons. Every time you are checking whether array of j is greater than array of j plus 1. If it is greater, you are swapping, else you are moving ahead. By the time you are reaching that n minus 2 iteration, elements automatically will be sorted. That I have proved it to you. Not only this, take any elements, any number of elements, follow the same thing whatever I have done, you would sort it. By the time you end the 10 minus 2 iterations, elements would be sorted. I hope I am completely clear with the working of bubble sort algorithm and the algorithm itself. Now we have to convert this algorithm to code. We will do it, but before that, copy this as it is. Be quick. I hope you have completed it. If not, please do rewind the video, complete it and move ahead, but I would continue. Carefully watch it. Now, that algorithm we have written, we have to convert it to working code. How? That you would understand. Say supposing I have a class. This is that class called bubble sort. Inside this class bubble sort, I have the main method. Public static void main, which would accept the string of args inside the main method. Well, inside the main method, I would create the object of scanner because many inputs I have to take from the keyboard. This is that scanner, scan equals to new scanner of system.in. Then I would ask the user system.out.println, enter array length. By seeing this message, the user will enter the array length. I would collect it by telling scan.nextInt and I would store it in a variable n which is of type integer. Now n has the array length. Now I will create one integer array like this. I need a new integer array as the same length as entered by user which is stored in n. For that array, I would give the name as ARR which is of type integer. ARR is an array. Empty array with the user entered length we have created, no elements are there. What will I sort? So I would ask the user like this, system.out.println, enter array contents. By seeing this message, user will enter the array contents. I would collect it by telling for. Starting from I equals to 0th index, go until I less than or equals to array dot length minus 1 I plus plus. Every time system.out.println, enter an element. By seeing this message, user will enter an element. I would collect it by telling scan.nextInt and I would store it in array ARR of ith index. That's it. So by the end of this loop, array contents would be filled. Now I have to sort it. Before sorting, how the array contents would look, that I would print off like this. Watch it. Probably here I would tell system.out.println like this. System.out.println array contents before sorting. Probably whatever user has entered, I have collected, that array contents only I will print. How to print, you have to tell start from 0th index, go until array dot length minus 1 I plus plus. Every time I would tell system dot out dot print. What to print? Whatever is there in array of I plus 1 space. Array contains one beside the other I have printed. Now many things again I will print on the monitor. It has to come in the next line. If it has to come in the next line, I would tell system dot out dot println, so that the cursor will come to next line. Array length is there, array is there, array contents is there, how it is there, that also we have printed. Now we have to sort the array contents in the ascending order by using bubble sort. How do you do it? Like this. See, this is the bubble sort algorithm. Probably I would tell start sorting the elements from the 0th index. From the 0th iteration. Go until I less than or equals to n minus 2 iterations I plus plus. In every iteration, you have to do some comparisons. So that the comparison, let it start from 0th comparison. Go until j less than or equals to n minus 2 minus I comparisons j plus plus. Every time, just check if at all the array of j is greater than array of j plus 1. If it is greater, what you have to do? You have to swap that array of j and array of j plus 1. If you want to swap, you need the help of third variable. Probably that third variable, let it be helping variable. Now you have to swap array of j and array of j plus 1. If array of j is first memory location, if array of j plus 1 is second memory location, I would tell whatever is there in first memory location, take it and give it to helping memory location. Whatever is there in second memory location, take it and give it to first memory location. Whatever is there in helping memory location, take it and give it to second memory location. This is how you swap the contents of two memory locations. That memory location is an array, that's it. This is the opening of the if, this is the closing of the if, this is the opening of the comparisons, closing of comparisons, opening of the iterations, closing of the iterations. By the end of these iterations, from 0 to n minus 2 iterations, by the end of all the comparisons in that iterations, the content should be sorted. Really will it be sorted? Might be your question. Probably I would print the contents after sorting like this. Possibly here I would tell system.out.println array contents after sorting. Here start printing the contents from 0th index, go until array dot length minus 1th index I plus plus. Every time system dot out dot print. What to print? Whatever is there in array of I plus 1 space. This is the closing of the for, that is the opening of the main method, possibly closing of the main method and closing of the class. Work is over. You take the array length, you create the array, you take the contents, print the contents how it is, sort it by using bubble sort. Then print it after sorting. That's it. You have to remember the algorithms very, very well. Linear search you remember, binary search you remember. Like that bubble sort also you have to remember. Two things only you have to keep in your mind. Iterations, comparisons in bubble sort. Iteration will start from 0, go until n minus 2. Comparisons in every iteration would start from 0, go until n minus 2 minus I. That two things if you will remember, work is fully over. Will it really work? Might be your question. Open the eclipse, like this. See, this is that bubble sort, fully bubble sort you have. Probably I would right click, run as Java application. It is asking enter array length. I would enter 5 only, 5. Enter an element 86, 42, 23, 18, 25. Now as soon as I click on enter, sorting using bubble sort will happen. Array contents after sorting would be printed. Of course, array contents before sorting, array contents after sorting. Everything would happen in the fraction of seconds. Look at it, enter, like this. I hope I am completely clear about bubble sort algorithm. Copy this as it is. This session we will be stopping it here. We will meet you in the next session. Until next session, please do take care of yourself. Happy coding and goodbye.